I really like the audio using my phone. I know it's bad. This audio is not very good, but it quadrupled the size of my file, and it's taking forever to download the 1 through 8. So yeah, I don't have enough time to do it. I mean, each one would take it's like taking like 45 minutes like total. So gonna have to zip ahead with minimal audio here. All right, so it looks like we're supposed to take the third derivative and we're supposed to evaluate it at x equals -1. So here's what we'll do. We will just go ahead and take the first one. And it's just a quartic polynomial, so no big deal. 28x to the third plus 24x to the second minus 10x plus 4. That's the first one. Okay, 28 times 3 is 2. What is that, 8? So that's 84x to the second plus 48x minus 10. Okay, here's the third. And 2 times 84 is 68. So 168x plus 48. Okay, and if we were to evaluate it at 1, it would look like this. Okay, and it would be 168 plus 48, which is 16. Carry the 1, 216 is your final answer. Okay. Of course, it's -1. So let's scrap that. -1. So what is 168 minus 48? And then we will make it negative. So that's -120. Okay. We already talked about this in class. So it looks like here, each individual one of those is its own function. It's like treat each one like a y. So that's why with each single one, you will get a d something dx. This is actually going to follow us when we work with something called related rates. So that if we wanted to take the derivative of the speed formula, we would have a d something dx happen every time. Or in that case, like a d something dt, because it's time. But anyways, we would just plug and chug there. This one is find the x-coordinates of all the points on the graph here at which the slope of the tangent line is 4. Okay, so the slope of the tangent line is 4, and they just want the x-coordinates. So if they want the tangent line, and they know that the tangent line, the slope of the tangent line is 4, let's go ahead and find the derivative of this guy. Okay, so that would be 3x squared minus 4x and plus 5. So what we want to do is set this equal to 4. Okay, so we're going to make it equal to 4. Okay, so now we have to solve this because we want the x-coordinate. So swing it over there, plus 1 equals 0. So now we have a quadratic. We want factors of 3 that add up to -4, and that would be -1 and -3. So now we have x minus 3 and x minus 1 equaling 0. But remember, this is the new AC method. Remember, we've got a 3 there, and so what we would do is we would just divide both of those by 3. So we have x equals 1, since 3 divided by 3 is 1, and this guy is 1/3. Okay, so those are the two coordinates at which the slope of the tangent line would equal 4. Okay, here we're going to find the equation of the tangent line. Okay, so I need more than slope. I need to have a point, and there's the point. Okay, cool. So if I want that, find the equation of the tangent line. Let's go ahead and, I already got the point, so let's go get the slope. So we're going to go ahead and take the derivative there, and the sine of 2x would be equal to cosine 2x times 2. So that would equal 2 cosine 2x. So that is the formula for all of the tangent lines, all the slopes of all the tangent lines of this particular function. This guy would be like a stretched sine function. Okay. So anyways, let's stretch the wave. So let's go ahead and plug in at pi. What would the slope be? So let's figure out, okay, what pi is. And we could have just wrote, okay, 2 pi. So what is the x-coordinate? because I say x because it's cosine. So what is the cosine of 2 pi? And that is actually the same that it is at 0. So the x-coordinate is 1 on the unit circle. So this means that 2 times 1 is going to be 2. So it looks like the slope there is 2. So therefore, my tangent line equals 2 times x minus pi plus 0. So I will just leave it like that. And if you want it in slope-intercept form, it would just look like that. Okay, but that is totally sufficient for us. Okay. All right, so now we're going to take the second derivative of this guy. Okay, so I see y equals, let's see. So this is, we don't actually have to worry about dy. We don't have to worry about implicit differentiation because y is by itself. So that's great. So this means that the first derivative would be the derivative of the outside, so that's negative 2 sine pi over 2 times, oops, sorry, x over 2 times 1/2. So that means we've got those two, well, let me explain it, right? This is actually 1/2 x. That's what x over 2 is. And so this means then that I would multiply the 2 times 1/2, that's 1, so that's negative 1. And so my derivative is this guy right here. Oops, I almost wrote pi again. Okay, that's the first derivative. And notice there is no other y prime for me to combine. So this guy is good to go. I can just do it again immediately. So y double prime is now, it's still negative because the sine derivative is cosine. Okay. I wrote pi again. Why is this pi over 2? I guess I'm just used to writing pi over 2. So x over 2 times 1/2. Okay, so that gives us negative 1/2 cosine of, let's see if I can do it. I did it. Okay, that is the second derivative. All right, let's see, we're at 7-minute mark. I guess we'll stop right there.